Good morning, friends. This is series of lecture for TYBSc Analytical Chemistry semester 6, and the name of the chapter is chapter number 6, flame emission spectroscopy. In the previous lecture we have discussed already about the introduction part of this chapter. Now in today's lecture we will study the principle of flame photometer, successive events that takes place in the flame, qualitative equation and the quantitative equation. Now here the basic part of this chapter is the principle of the flame photometer. The principle of the flame photometer is based on the measurement of the emitted light intensity when a metal is introduced into the salt. Now here the basic principle is the measurement of light intensity emitted when a metal is introduced into the flame. The wavelength of the color gives the information about the element, and the color of the flame gives the information about the amount of element present in the sample. Now here the qualitative equation, with the help of color we gain the information about the element, which element is present. Accordingly we get the qualitative estimation, and the intensity of the color that will give the amount of the element present in the sample, that means quantitative estimation. When a liquid sample containing a metallic salt solution is introduced into the flame, now there is a sequence of events takes place. The first, the solvent is evaporated, leaving behind salt, dry salt. Now the first event that takes place is nothing but the solvent is evaporated. The second is the dry salt is vaporized or converted into gaseous state. The third part is a part of, or all the gaseous molecules are progressively dissociated to give free neutral atoms or radicals. And the last one is some of the neutral atoms may combine with the radicals in the flame to form new gaseous compounds such as a metal oxide, and this metal oxide gives the chemical interferences in this technique. Now this is the second point of this video, that there is a successive event takes place. The first, solvent is evaporated, the dry salt is converted into gaseous state, the third part is formation of neutral atoms or radicals, and the fourth part is the combination of these neutral atoms with the radicals to form metal oxides, which will give rise to the chemical interferences. Now the third point is the qualitative equation. Now this is the qualitative equation. With the help of, we get the value of lambda, and this lambda is the deciding factor for the qualitative analysis, or we get the what is the element is present, information about the element from this value of lambda. Now when the atom or neutral atom will get excited, at that time there is a change in energy level takes place. This change in energy level is indicated by E2 minus E1, which corresponds to that E2 is the higher energy state and E1 is the lower energy state. H is the Planck's constant, and we know the mu is equal to C upon lambda. Therefore E2 minus E1 is equal to H mu, and when the mu is but value of mu is equal to C upon lambda, we put this value, that is E2 minus E1 is equal to HC upon lambda. This is the product which is constant HC, where H is the Planck's constant and C is the velocity of light. the product of these two values is constant, and we know the value of E2 minus E1, that is energy difference, and lambda that can be calculated is lambda is equal to Hc upon E2 minus E1, so that we get the qualitative analysis. Quantitative analysis is also the simple. The Boltzmann distribution equation that can be employed for the qualitative analysis or quantitative equation, where this is the ratio of fraction of total number of thermally excited atoms. The fraction of free atoms that are thermally excited is given by this ratio Ni upon N0. Ni upon N0 is equal to Pi upon P0 into e raised to minus delta E upon Kt, where K is the Boltzmann constant, delta is the difference, T is the temperature of the flame, Pi and P0 these are the statistical constant, and Ni is equal to number of excited atoms, N0 is the number of atoms present in the ground state, and this Ni upon N0 is the fraction of number of total number of the free thermally excited atoms. So we get the quantitative estimation with the help of this Boltzmann distribution equation. So this is all about this sequence, the basic part of this chapter, that is the principal successive event takes place in the flame, quantitative equation and qualitative equation. So all about this. With this content I conclude this lecture. Thank you very much for your patience listening.